बेटा हु इज डीके यादव? आप अपना बेटा हाँ म्यूट है ना? ये भैया शादी करनी।
Welcome on the National Workshop on Virtual Labs under IIT Kanpur at Government PG College Badaun. You are most welcome, the faculty available here from the entire country. This is fourth day of this National Virtual Lab conducting by Government PG College Badaun affiliated to MJP University Bareilly. Now, this is the day for the experiment, virtual experiment discussing for BSc second year, semester third, the syllabus provided by MJP University as per NEP 2020. So, without any delay, I would like to invite our keynote speaker for this popular lecture, Dr. Aparna Dixit. I welcome Dr. Aparna Dixit ji. You may please continue the talk. Thank you.
Sure, sir. Can you see my screen? No, आप स्क्रीन देख सकते हैं? Yes, ma'am.
Yes, ma'am.
Fine.
Visible.
Now again we will start with vlab.co.in. So now we can see the objective, whatever being discussed by Sumantra Party by yesterday. You can see areas of virtual labs, electronics and communication, computer science and engineering, electrical engineering, mechanical, biotechnology, civil engineering, physical sciences, right? So here you can see the advanced mechanics virtual lab. You can go through it and check experiment here. Suppose if we click on compound pendulum, right? So this is your aim, is already given there, and then you can see entire theory. Go to the simulator. So this is the compound pendulum. So before going through simulator, we can click on procedure. So in procedure, you can see the performance, how to perform the experiment in real lab. Okay. So basically this scale is suspended to the axle itself. And these are holes. At different hole actually, we can maintain the distance, different distances. We can find out the period, time period t. Okay. So when you go through, wait a minute. So in the same way, you can see here just make a table, then write a result here, then you can go for the simulator. How to perform simulator? Mass is already given 1 kilogram. Here you can change the environment, okay, and then 5 to 9, okay. So just we choose some value here, suppose 5 centimeter, then this value, let us choose some other value, 15 centimeter, okay. Now you can apply, then on the experiment, write here the value, distance of edge, and try to find out T1 and T2 time, find out mean time, okay, number of operations. So this could be done from here. This is one example of the lab. Similarly, you can go for other labs also, okay. So maybe this is not a part of your lab, okay. Just wait a minute.
Screen is not
Yes, beta.
visible, ma'am. Screen is not visible, ma'am. Please check
Is
it
it
once.
visible now? Is it visible now?
Yes, it is visible, ma'am.
Yeah, beta, I think there should be some network issue from your end. Please check your. You may leave the meeting and then join again. Okay.
Yes.
You may leave the meeting and join again. Then you can see. If you feel the problem, then you can restart your Google Meet. Okay. Maybe the issue from there. Okay, I am not visible.
Yes, ma'am.
Is it fine now? Okay.
It's fine.
Okay. Now let's go back and try to understand other experiment. So I'm just telling you some example of virtual lab that you can find here, right? Okay. Now again, you can go for basics of physics lab from IIT Kanpur. When you click on, you can see some experiment, right? List of experiment is here. Carey-Foster bridge, energy band gap, viscosity of liquid, specific rotation of cane sugar, focal length of the combination of two lenses nodal slides, wavelength of monochromatic source of light with the help of Fresnel biprism, and the polarization of light using helium neon laser, and so on. Right? Now, if we go back, wait a minute, then go to electricity and magnetism. Amrita Vishwavidyapeeth, you can see some experiment. Now you can see here one of the experiment, Anderson bridge. Okay. So what is the objective of this bridge? With this experiment, what we do, we determine the self-inductance of the coil using Anderson bridge. If we talk about bridge, that means you need to, in electricity, in magnetism, you need to balance the resistances. So how to balance the resistances? Wheatstone principle is the only way by which we can basically balance the resistances. Okay, just making a Wheatstone bridge. Now again, what is the next objective? To calculate the value of inductive reactance whose symbol is XL of the coil at a particular frequency. That means we have to fix a frequency. Okay, so now you can go with the theory, right? And then you can see some theoretical part, go to the procedure. So when you click on procedure, how to perform in a simulator, it is given there. Okay. So slider region, signal generator, voltage, this slider is used to vary the voltage of the signal resistor. Frequency. Using the slider, we can fix the frequency for a particular voltage. For inductance coil length, this slider is used to change the length of the inductance length coil used in the circuit. So how many number of turns there in 1 meter length of coil? Go back to the simulator and try to understand how it looks like. Network issue? Yes, you can. Now you may connect this one. And this one. Okay. So now you can have idea. Suppose the operators would be there. So how will you connect from a resistance box and all these? Okay. So this is the way. Now you can click on this 3 line. After balancing, proceed with Anderson bridge. तो पहले balance करना है, right? That is P upon Q is equal to R upon S in the resistance. Okay? So once you balance the resistances, just take a ratio of them, like go to the procedure and try. Length is given there, and the diameter. This slider help us to fix the diameter of the core material of the coil. This is the next step. So first of all, you will do all this, and then Wheatstone bridge, power on. Okay. So you can see the next part. You can put here accumulator, the battery, inductor. Okay. So everything. So we have to go back simulator. Simulator में हम फिर से देखें क्या है. Okay. Just wait a minute. Okay. You may call me tomorrow. Okay. So now you can see the bridge here, and then Wheatstone bridge first. So first of all, we make a connection first. Wait a minute. First of all, let's make a connection. Okay. Fine. Now I think this one is left. Nothing is left now. You can see any thumb? No. All are connected. Fine. Now to start power on. Now you have to select. You may keep all the 0.1 small one. All 0.1. This is 0.1. You can choose them same. Okay. Again here. Now you can balance here. Then you can make some connections. Wait a minute. This is connected. This one is left. Again, you can see, just check whether it is connected or not. One is still left. Beta, right now I'm busy in workshop. Can you please come at 4:55? Please. You can see any connection is left. Dear student, can you please tell me any connection is left? Which you can see here. कोई connection हमारा छूट रहा है? एक बार check कर लो. And respond to me. Any connection is left? बेटा कोई connection छूट रहा है?
I think no, ma'am.
No. Fine. So what do we do? Just click on here. Okay. So now you can set the power on, power after balancing. Alright. You can see the result before going through Anderson Bridge. में गए हम लोग and then click on it should be, but just click on this signal generator. We have to keep this value first of all, right? And then see the result. Again, just go back to procedure and check slider region, signal generator. Slider is used to vary the voltage of signal generator. Then whatever you can do, just go back. Then again you can keep all the things like just take a just balance the ratio of resistances by keeping the balance or making a Wheatstone bridge there first. Okay, then you may click on that one by one Wheatstone bridge. So first of all Wheatstone bridge करेंगे हम फिर से again, right? आप बेटा जितनी प्रैक्टिस करोगे ना उतना ही समझ में आएगा. This is most important to practice. Keep continue yourself on only practice. Okay. So any connection is left? Yes. Anyone? Any other? No, not at all. So now you can go to the start power on. Power on, you can see 0.04. Okay. Now if you change the value, how to go for? Keep small. फ्रैक्शनल में जाए अगर हम तो फ्रैक्शनल में तो और भी अच्छा है. Just keep 0.5. Close it. And here small. बहुत ज्यादा हो गया. Again, you can choose here the different values. Just give some random values and try to understand क्या होगा. ठीक है? You can see the different change values. Fine. Now, if you go with Anderson bridge, then you can change the coil length, coil diameter, signal, generator. Once you balance the resistance just by making Wheatstone bridge here, all these will glow red, and then you can change the values on the slider, coil diameter, signal generator, frequency. You can choose from 20 hertz to 200 hertz, and you can make shift a variable resistance here, and then click on the result. You can see the result here. Okay, so you can put here values PQRS for the variable resistance, just keeping fixed frequency 100 hertz में 200. Suppose हम शुरुआत कर रहे हैं frequency 20 hertz है. You can put some more like 40, 60, 80, 100, 120. Because I think ये 20 hertz से लेकर के 2000 hertz तक है frequency यहाँ पे. ठीक है? So you can choose here these value and then perform the experiment. Go for the self evaluation. Whatever you have, you could understand. Just you can test your knowledge. ठीक है? And then after going through simulator, you can go for the assignment. So this is a bunch of numericals. You can perform the values. So put the input values, and by applying formula, just choose the condition, read it carefully, and then try to find out answer निकालने की कोशिश करो. Okay, and the similar questions I think आपके पास syllabus में होते हैं, वो similar questions आप उनको करिए. For your knowledge, these are some references. You can say Raymond, ये book बहुत ही important है. ये Pacific Group ब्रूक्स कॉले की बहुत ही important book है. ये जो तुम्हारा माइग्रे हिल का है, ये भी बहुत अच्छा है. आउटलाइन ऑफ शॉम सीरीज आती ना, तो अगर जिसको भी जाना है, जैसे कि हायर एजुकेशन में जाना है, ठीक है, लाइक रिसर्च करना है, ठीक, या किसी रिसर्च लैब में काम करना है, so they will have to qualify competitive exams. So for competitive exams, actually this book is most important, ठीक है. And you can click on this bibliography भी दिया हुआ है, click on this. I think ये तो इनका अपना इशू है, रेगुलर मेंटेनेंस, इसलिए वो दे ही नहीं रहे हैं. वेबसाइट कभी दे दी थी और शायद उसे अपडेट नहीं किया. IAS की साइट पे जाकर के देख सकते हैं एक बार क्या है, ठीक है. So again the error can be seen, Indian Academy of Sciences, maybe some technical glitches, इनका कुछ अंडर मेंटेनेंस होगा तो नहीं हो पा रहा है. फाइन, नॉट एन इशू. सो जिस तरह से आप लोगों ने एंडरसन ब्रिज किया है, यू कैन परफॉर्म अदर एक्सपेरिमेंट ऑल्सो, ठीक. वेन डायग्राफ जनरेटर कर सकते हैं. वेन डायग्राफ जनरेटर आप लोगों ने पढ़ा है ना सभी ने. तो व्हाट इज द ऑब्जेक्टिव, क्या ऑब्जेक्टिव होता है, क्या करना होता है? डिस्चार्जिंग एक्शन ऑफ sharp points. Electron discharge takes place in air, gases at pointed conductor. The charged conductor is brought in water. All of its charge transfers to the surface of the hollow conductor, no matter how the potential of the letter B. So you will apply some formula here. So you can see the large conductor and this small conductor here consists of large metal sphere mounted on an insulated support, endless belt, you can see B. So entire theory can be read here, and then you can go for the performing the simulator turn on off, use to power on of Van de Graaff generator. Van de Graaff generator आपको पता है, Van de Graaff generator, if I am not wrong, it was first developed by TIFR people. Even you can see their Van de Graaff generator is still the oldest one. जो सबसे पुराना था वो अभी भी देख सकते हैं, ठीक है. तो ये हमारे क्या है, कुछ इस तरह के डेवलपमेंट्स हम वर्चुअल लैब में देख सकते हैं. सपोज Van de Graaff generator is not available in your lab, but it is the part of your syllabus. You can perform the experiment, you can better understand with the help of virtual lab. Okay, so then you have to go like just read it carefully, then go to the simulator and perform the experiment. So what do they help us? Switch, turn on off, use to power on off the Van de Graaff generator. Dissect and cover, this button used to see the inside of the Van de Graaff generator. Slider में क्या कर सकते हैं? We can change the length. This is used to change the length of 2 speed. Now power on the Van de Graaff generator by using switch turn off, change the length and observe the discharging time. ये हमें देखना है. Now go to the self evaluation. We did not. Can you see my screen? I think someone is trying to present. This is my humble request to the students, like those who are willing to present their screen. So how can I present?
Students, do not present the screen.
ठीक है, आप बच्चे करोगे तो मैं कैसे प्रेजेंट करूंगी? सिंपल सी चीज है, राइट? ओके, कैन यू सी माय स्क्रीन?
Yes, ma'am.
Okay, fine. So now click on simulator. You can see the picture of simulator here. This is the large conductor and the small conductor. Okay. Now go through the variables, then result, turn on. You can see the adjust the distance, you may adjust distance, suppose you may put here 2, then dissect, you can see the, can you imagine, ऐसे charge आपको experiment में दिखेगा? No, you should keep some detector and then you can see the trajectory of the charged particle, right? Now, whenever this positive charge get transferred to this small conductor, some lightning is there. And can you imagine, जो कि हमें आसमान में दिखता है वो हम यहाँ देख रहे हैं कैसे लाइटनिंग हो रही है, राइट? अच्छा, मुझे ये बताइए कि ये जो लाइटनिंग हो रही है, व्हाट इज दिस टाइप ऑफ करंट? कौन सी करंट है ये? Is this a conduction current or a displacement current? Lightning हो रही है, that is electricity produce हो रही है. जल्दी बताना. Anyone? कोई बताना चाहेगा? Connected to the battery one by one. क्या कर रहा है? चार्ज यहाँ पे स्लाइड होकर के आ रहा है. Collected to the large conductor, spherical. Okay. So this from this conductor, positive charge is get transmitted to here, and then you can see the lightning. Okay. इस क्वेश्चन पे थोड़ा सोचना कौन सा करंट है. Now go for the cover. Then again, you can go with the turn on. You can change the like 3 पर कर सकते हैं and see the transfer of that charge. Fine. So this is the beauty of virtual lab, where you can see this, how it is going on, right? This is most important, cannot be seen very clearly in the physical labs. Okay, you can focus on the fundamentals here from, otherwise physical labs में हम एक चार्ज पार्टिकल को नहीं एज्यूम कर पाएंगे, देख नहीं पाएंगे. Okay, it's a very small stroke, quantum size है, बट यहाँ आपको वर्चुअल लैब में दिखाई दे रहा है. So this is the part of Venn diagram generator. Now go to the assignment. Assignment में क्या? Draw a neat level diagram of Venn diagram generator. Then actually questions are only there, no numericals, but you can prepare these questions for the competitive exams because you must know all the things. Fine. तो ये तो हमें आनी ही चाहिए. Now if you go for the next experiment, deflection magnetometer. Alright. Deflection magnetometer, what is the aim of this? Magnetic dipole moment measure. किसका? Of a bar magnet. And horizontal intensity of Earth's magnetic field using a deflection magnetometer. Right? So this is the theory part which is to be followed by us. हमें ये follow करना है. Sorry. Now try to understand how same experiment via simulation कैसे perform करेंगे. So you can select vibration magnetometer. then length of the magnet, mass of the magnet, breadth of the magnet, that is dimension of the magnet. Place second magnet, choose a position, choose the side, place the magnet, distance from the center. Okay. शगुन गुप्ता जी, कौन है आप? आपसे एक रिक्वेस्ट है कि आप अपनी स्क्रीन को प्रेजेंट ना करें. फाइन. Otherwise, I will not be able to present mine. Is it clear? बेटा बेसिक के स्टूडेंट हो, लेकिन ये अपनी तरफ से कोशिश करो, है ना, कि कैसे करते हैं. ठीक है. जब आप प्रेजेंट करोगे तो मैं कैसे प्रेजेंट करूंगी, आपको समझना पड़ेगा. राइट. ओके. कैन यू सी माई स्क्रीन और नॉट? नो. Again, I am going to present the screen first. Is it clear now? Can you see this?
Yes, ma'am.
Yes, ma'am.
Okay. So you can follow the slider region first. कैसे कैसे करना है? Vibration magnetometer select करना है. ठीक है. For measuring the time period of the oscillator of bar magnet. Okay. Length of the magnet कैसे करेंगे? Set the horizontal length of the magnet. कहाँ से सेट कर सकते हैं? From 3 centimeter to 7 centimeter. Mass of the magnet. Go to the simulator and do the same thing. Okay. Now you can see here simulator. You can see the picture of simulator. Let's come out. Actually बीच में जब sharing कोई screen करने लगता है ना, then again same problem will be experienced by me. Okay. So wait a minute. Vibration magnetometer, huh? We have two options, vibration magnetometer and deflection magnetometer. Deflection ले आते हैं. Okay. What is the mass of the magnet? Let us choose some value. Let us choose 35. Length of the magnet from 3 to 7 है. 3.2 रख लिया. Breadth of the magnet, it can be from 1 to 3. So better is to keep at 1.2. Okay. And then place the magnet. Magnet को place के deflection देगा. Okay. Show the result. Time period कितना है? 0. You can see this timer clock. Fine. Time oscillations is all given here. ठीक है. What is the moment of inertia? 3.41 into 10 to the power minus 6 kilogram meter square. So again, you can reset. Then choose, suppose we choose vibration magnetometer. So position of the tan B, right? Rotation angle. Suppose 20 degree हमने rotate करा दिया. Select the side हमने A select किया. Place the magnet को place किया. And distance suppose 50 तक ले जा सकते हैं. So take distance 10 ले लिया हमने. हाँ, अब हमें दिख रहा है ढंग से, है ना? ठीक है. Now you can note down the pointers reading, oscillations there. Okay, you may put the length of magnet here, breadth of the magnet here, everything, and then just you can change the slide. Side earlier it was A, now it is at B. Place the magnet, reverse magnet, and then can change the value. Suppose at the same distance,
दोनों में कैमरा लग गया.
10 centimeter. Can see the result, moment of magnet. Magnetic moment is 0.6 and intensity, magnetic field intensity is 3.6 to the power 10 to the power minus 5 Tesla. So this is the beauty of experiment you can use here. You can start experiment via two more, vibration magnetometer and deflection magnetometer. So with the help of deflection magnetometer, we can measure other things. On vibration magnetometer, we can basically measure out other things. Okay, so if there is any question, you may ask here because we have completed all the experiments here. In this electricity and magnetism, I have shown all. So if you have any question, you may ask me, and so that this session could be interactive. मुझसे क्वेश्चन पूछ सकते हैं, राइट? एनी क्वेश्चन? अच्छा, आप लोगों में से कितने लोगों ने कल का एक्सपेरिमेंट परफॉर्म किया? कैन यू प्लीज रेज योर हैंड और जस्ट राइट द मैसेज. ओके, खान ने किया, पूर्वी ने किया, दक्षा ने किया, श्रीजिठा ने किया, और आकाश ने किया, अभिनव ने किया, हर्षिता, सुप्रिया, उन्नति, मिनी ने किया. गुड. और बाकी ने क्यों नहीं किया? आकाश ने.
जिन्होंने किया भी है, उनको कोई इशू आया हो, कोई प्रॉब्लम हुई हो, तो यू कैन आस्क.
हाँ बेटा, जिन्होंने किया अब वो मुझे बताए कि उनको कोई इशू आया. आपको कैसा लगा? आपका क्या एक्सपीरियंस था? How was your experience while you performed the experiment there? Okay. Can you speak up here, Daksha? दक्षा, आप अपना बता सकते हैं कोई इशू? नहीं. Experience was too good. Would you like to speak something?
Abhinav Rathore.
Yes, ma'am. It was a great experience. I performed one experiment that was a one digraph generator, but I could not take the result. That was the issue with me.
First you have to introduce yourself. First you have to introduce yourself when you will going to speak during this workshop.
Yes, ma'am. Yes, ma'am. My name is Aparna Dixit. I am a student of BSc third semester from Government Degree College, Badaun. So I performed one experiment from virtual lab that was the one digraph generator. So I performed the whole simulator. I used the simulator. That was a great experience. but the result was not there, so that was the issue in that.
In Van de Graaff generator, you can see actually the transfer of charge from the large sphere to the small sphere, spherical conductor, right?
Yes, ma'am.
Is it so or not? So the lightning can be seen through when the transfer of charges can be seen.
Yes, ma'am, it was
Is it
there.
right, right. So up to here only we have to do. We have to understand the concept of like how the charge is basically coming from the large spherical conductor to the small spherical conductor. Right. The process of entire transformation of charge. Okay, how they are taking moving ahead from one conductor to another conductor. So it was there. Right.
Yes,
So
ma'am.
you may perform another experiment also. Just go there and perform the experiment.
Okay, ma'am, I will definitely perform the other
Right.
experiments.
If you feel still any problem, you are in the group. You can put the message to me. I am included in that group. You can find out my number and try to give me whatever the issue is going on. Okay.
Okay, thank you, ma'am.
Yeah. Anyone else? Okay. So can I leave the meeting now? If you people allow.
Okay, ma'am, you can leave. Now I would like to request Madam Suman Tripathi. She is from IIT Kanpur. She is a senior project associate. Uh, Actually, some participants from all over the country are interested to uh, have the uh, internship from IIT Kanpur. So I would like to request to the Suman Madam to address all such type the participants and the faculty to maintain the virtual lab notice center with IIT Kanpur. Madam, please speak about this issue.
थैंक यू सो मच सर। देखिए, अभी जो भी हमारी नेशनल वर्कशॉप चल रही है आप उसके थ्रू तो सीख रहे हैं। अपर्णा मैम आपको बहुत अच्छे से सिखा रही हैं कि क्या है, कैसे क्या फिजिकल लैब करनी है। अगर फिजिकल लैब नहीं है तो आप वर्चुअल लैब की मदद से कैसे काम कर सकते हैं। मैं एक अनाउंसमेंट करना चाहूंगी कि जैसे इस वर्कशॉप में डिफरेंट स्टेट से फैकल्टी मेंबर भी जुड़े हैं जो किसी कॉलेज से और इंस्टीट्यूट से जुड़े हुए हैं। तो अगर कोई चाहता है कि इस नेशनल प्रोजेक्ट में आईआईटी कानपुर के साथ जुड़े तो वो हमें नोडल सेंटर के लिए अप्रोच कर सकता है। इसके लिए ग्रुप में आपको संजीव सर एक गूगल फॉर्म की लिंक देंगे। उस गूगल फॉर्म लिंक में आपको सारी इन्फॉर्मेशन देनी है और वो इन्फॉर्मेशन मेरे पास आ जाएगी। तो देन आफ्टर हम लोग आपको एज अ नोडल सेंटर आईआईटी कानपुर का बना सकते हैं और उसके थ्रू जो बच्चे इंटरेस्टेड हैं वर्चुअल लैब में काम करने के लिए, इंटर्नशिप प्रोग्राम में पार्टिसिपेट करने के लिए, उनको हम इजीली अपने साथ अंडरटेक कर सकते हैं। तो सबसे पहले अगर आप कोई भी इनिशिएटिव इस कानपुर के साथ करना चाहते हैं तो आपको एज अ नोडल सेंटर पहले इनके साथ जुड़ना पड़ेगा हमारे साथ। तो संजीव सर प्लीज इनको गूगल फॉर्म आप प्रोवाइड कर दीजिएगा तो जिससे सारी फैकल्टी अपनी इंफॉर्मेशन को फिल कर सके।
Yes, ma'am. Yes, ma'am. I will do it. And I would like to one more request. We have share the one feedback for the participants too. Uh, they are interested to have the internship from IIT Kanpur. We have to collect the data of the such type of participants all over the country and to submit the to IIT Kanpur uh, for the welfare of the students. Uh, it is my request, madam. ऐसे पार्टिसिपेंट जो कल से हमारे पास रिक्वेस्ट कर रहे हैं।
सर 5 मिनट में एक कॉल पे हूँ, मैं अभी करती हूँ आपको रिप्लाई। सर
थैंक यू। अगर कोई ऐसी प्रोसेस आती है तो पार्टिसिपेंट्स को भी हम गूगल फॉर्म के थ्रू ऐसा इनविटेशन दे सकते हैं, वो इंटर्नशिप के लिए आईआईटी कानपुर अपना अप्रोच कर लेंगे। थैंक यू। नाउ आई वुड लाइक टू रिक्वेस्ट टू द डॉक्टर श्रद्धा गुप्ता, हेड ऑफ द डिपार्टमेंट ऑफ फिजिक्स, गवर्नमेंट डिग्री कॉलेज बदायूं, to deliver the vote of thanks during this session. Madam Shraddha Gupta.
Thank you, sir. Am I audible? थैंक यू सर। सबसे पहले मैं हमारी वर्कशॉप से जुड़े सभी फैकल्टी मेंबर्स को थैंक यू बोलना चाहती हूँ कि वो जुड़ के हमारी वर्कशॉप को सक्सेसफुल बनाने में हमारा साथ दिया। सभी पार्टिसिपेंट को कि उन्होंने जुड़ के यहाँ पे बेनिफिट लिए। अपर्णा मैम को जिन्होंने हमारे यहाँ जुड़ के उन्होंने बच्चों को वर्चुअल लैब के बारे में बताया और उसमें हम कैसे एक्सपेरिमेंट कर सकते हैं और उसके बेनिफिट्स बताए। बहुत सारी चीजें जो हम फिजिकल लैब में अवेलेबल नहीं कर पाते हैं, बहुत सारे पैरामीटर्स है, जैसे लिमिटेड रिसोर्सेज हैं, हम बहुत सारे अननोन वायर्स या कोई अननोन थिंग्स नहीं प्रोवाइड कर सकते। वो जो पैरामीटर में वेरिएशंस हैं जो हम फिजिकल लैब में हमारी लिमिटेड होती है, वो हम वर्चुअल लैब में उसको और एलैबोरेट करके देख सकते हैं और एक्सपेक्टेड रिजल्ट को काउंट कर सकते हैं, वो मैम ने बताया। और मैं सुमन मैम का भी थैंक यू बोलना चाहूंगी कि उन्होंने बच्चों को वर्चुअल लैब की इम्पोर्टेंस और उससे ज्यादा उसमें इंटरेस्ट क्रिएट करने में हमारी बहुत हेल्प की है कि बच्चे उसमें इंटर्नशिप करना चाहते हैं। और एक IIT कानपुर ने भी एक अपॉर्चुनिटी दी है कि बच्चे जो इसमें इंटरेस्ट दिखा रहे हैं, गूगल फॉर्म के द्वारा हम उनका डाटा कलेक्ट करके IIT कानपुर को सबमिट करें, ताकि उन बच्चों को जो बहुत छोटे स्केल पे वो नहीं इनके पास इतने रिसोर्सेज या इतने प्लेटफॉर्म्स नहीं है जिससे वो खुद कांटेक्ट करके कर सके। तो हम इसमें अपने आप को खुशनसीब समझते हैं कि गवर्नमेंट डिग्री कॉलेज एक ऐसा प्लेटफॉर्म दे पा रहा है जिसमें ये बच्चे इसके थ्रू IIT कानपुर के थ्रू जुड़ सकते हैं और अपनी इंटर्नशिप या अपनी क्रिएटिविटी को और अपने इंटरेस्ट को इसमें शो कर सकते हैं। थैंक्स टू डॉक्टर संजीव राठौर सर, जिन्होंने ये प्लेटफॉर्म फैकल्टी मेंबर्स एंड स्टूडेंट्स को प्रोवाइड कराया, जिससे बच्चे अपने ड्रीम्स को फुलफिल कर सकते हैं। इसलिए मैं बच्चों से गुजारिश करती हूँ और अदर फैकल्टी मेंबर्स जो इससे जुड़े हैं वे अपना इंटरेस्ट इन गूगल फॉर्म में शो कर सकते हैं फीडबैक फॉर्म के थ्रू, और इनको हम IIT कानपुर के थ्रू इनको कनेक्ट कर सकते हैं। और इन्हीं शब्दों के साथ धन्यवाद सर।
थैंक यू मैम।
Any participants? Any problem? Anybody else? No. Thank you.
No problem, madam.
So
No, sir.
session is over now. You can leave the meeting for today. You have to submit the feedback form within time. We will going to share this feedback form on the groups. Thank you.
Thank you, sir.
Thank you, sir.